Well, what happens when you mix aluminum sulfate and ammonium nitrate solutions together? Will there really be a reaction? Well, let's see. Let's walk through the molecular, the total ionic, and the net ionic equations. And once we've done that, I'll show you pictures of it, and we'll see if what we've written down matches experimental results. Okay, so if this is going to be a metathesis reaction, then the cation of one will potentially react with the anion of the other. So one potential product is aluminum nitrate. What's the other one? Make sure cation before anion. Let's take the names of each and turn it into a chemical formula, and then combine those chemical formula into a chemical equation that's properly balanced and it has state labels. So don't forget previous work. How do you write aluminum sulfate? What's the charge on the aluminum ion? 3 plus. What's the charge on the sulfate ion? 2 minus. How do you write ammonium nitrate? Well, the charge on the ammonium ion is a positive, and the charge on the nitrate ion is a negative. And when you write the products, just make sure you write them properly. When you write aluminum nitrate, it's not Al2NO3. What is it? You got to do the positive 3 from the aluminum ion and the negative from the nitrate. Don't worry about a balanced chemical equation yet. Write the substances properly. How do you write ammonium sulfate? What are the charges on the cation and the anion? Now we have to balance it. So take a moment, write it down, and try to balance it. Pause this while you're doing that. So you got it? Okay, if you didn't write it down, I know who you are. I will come and find you. Don't just blow through this sucker. Actually do the work. Write it down. What'd you get for the coefficients? Balance the ions. Now, we need state labels. What's the rule on aluminum sulfate? Well, there's no aluminum general rule, but there is a sulfate general rule, that they're soluble with some exceptions. Is aluminum one of the common exceptions? No. So these are all in water. It's soluble. AQ. What about this one? Ammonium compounds are soluble. AQ. What is it? Nitrates are soluble. And this one. Well, we're back to ammonium compounds are soluble, therefore NaQ. If you understand the solubility rules and what it really means for all of these to be soluble, you can write the net ionic equation right now in about 2 seconds. let's walk through. Maybe you can't see it right away. That's okay. Let's walk through this. The total ionic equation takes each of the substances and then breaks them up into ions when appropriate. What do you do with this? Well, since aluminum sulfate is soluble, that means that it dissociates into aluminum ions and sulfate ions, and you keep the 2 and the 3 there as coefficients, not as subscripts, because every aluminum sulfate that dissolves provides 2 aluminum ions and 3 sulfate ions. Ammonium nitrate gives you ammonium ions and nitrate ions, but we have a coefficient. So that 6 has to get propagated across to the cation and the anion. The aluminum nitrate, soluble. The 2 gets propagated across. Be careful. Yeah, we get 6 nitrates because it's 3 nitrates from every aluminum nitrate, but there's 2 aluminum nitrates in the balanced chemical equation. And then this one, you get ammonium ions and sulfate ions. How many of each? Well, it's 6 ammonium, because 3 times 2, and it's 3 sulfate. Reminder, when you write the total ionic equation, you're not looking at your solubility rules anymore. You're looking at what you wrote in the molecular equation, because that's when you decide whether it's soluble or insoluble. The total ionic equation is just expressing that appropriately. Now, the net ionic equation. Well, let's go and find spectators and see what happens. Okay, we have 2 aluminum ions in the reactant, 2 aluminum ions in the product. Gone. Spectators. 3 sulfates in the reactants, 3 sulfates in the products. Gone. Spectators. See a pattern? Ammonium and ammonium. Okay. And nitrates. 6 nitrates reactants, 6 nitrates products. Hey, what's left over? Is there anything left over? So what do? You need to write something. No reaction, no precipitation, whichever. But you have to write something to show that you understand that nothing is supposed to happen. See, just because I write that as a molecular equation doesn't mean that anything happens. All that really happens is when you mix aluminum sulfate and ammonium nitrate, you get a mixture of ions, but no precipitate is formed. So these are actually test tubes of these solutions, and you can see no precipitate.